they're both quite important as part of the, where's this thing happening? As part of the photosynthesis process specifically. So manganese is especially essential for splitting water in that photosystem 2 complex. And then zinc it's part of enzyme activation. It stabilizes the structure of photosynthetic proteins. Essential for cellular division and elongation. So this is also important as this works together with IBA or IIAA auxins. And both of these are important in the hormonal regulation of growth responses. So for root architecture, we know auxin is important for new root development and then also seed germination. Okay, so as I said previously, plants may not actually exhibit visual deficiencies, but they are already deficient. The nutrients might already be deficient. And that will already impact your growth in terms of either shoot length or the quality of the plants. It might impact your post-harvest quality, but it goes undetected. So also the value of doing a plant leaf analysis is that it also acts as an early warning system. So if you do the analysis and you can see your levels aren't quite right, you can do something to ameliorate the situation before it becomes a problem. Okay, so we know Proteas prefer a well-drained soil. I mean, everywhere I go, the most important thing to me is that it's well-drained. They shouldn't be standing in any form of water for a long period of time. And often a well-drained soil is connected with a higher sand content, obviously, and that is often also linked, especially with us in the Western Cape, where we have very sandy soils, low micronutrient levels. And then as a producer or a grower, we are confronted with so many different products. There's liquid products, there's products like in a powder form. It's either the sulfate form, like it's more traditional, almost salt form, or it can be chelated with various different things. Normal or sort of the older EDTA chelates, amino acid chelated products. There's so many products available that you're bombarded with, and everyone, they do really great marketing. The uptake of this product is the best ever, and you only need to apply so little, and then it's going to work. So, and it's difficult to get real data from the marketers and really talk to technical people to see what really works and what doesn't work. So that was part of why we're doing the study. These are just a couple of different products out there. And they have fancy names, and yeah, it's a bit of a minefield some days. So the aim of this study was then to basically look at the efficacy of micronutrient foliar sprays. If we spray it, do we see anything happening in the first case? So is there like uptake, or is it just we're just spraying something and it's not really doing anything? To obviously maintain that optimum nutritional status during the vegetative growing season. So I always think, while the shoots are growing, whether it be Protea in flushes or a Leucospermum, which is like basically just one long growth season, we need to support that growth while it's growing. And I think Dennis also said the same thing, while it's growing, we need to support it, because there's a point where it's done. So I looked at two different products. The one was an amino acid chelated product, zinc and manganese, and the other one was a sulfate-based zinc, just a normal zinc sulfate and manganese sulfate. And with that, I added relatively inexpensive fulvic acid that sort of acts as my own little chelating agent. So fulvic acids are small water-soluble organic compounds. You get the humic acids as well, which is the bigger compound. They're rich in that reactive carboxyl and hydroxyl groups, and effectively then chelates and then transport the nutrients. So I like adding that to my foliar sprays. And then lastly, I just did a little cost analysis to see what's the difference in price if I now use the traditional sulfate product versus fancy chelated product. Okay, and I used 4 different pincushion cultivars. So I used Succession, Soleil, and this was at the same farm on top of Piketberg Mountain. I'll show you now. And then Ayoba Sun and Tango at Bugler's Post, which is another farm, also on top of Piketberg Mountain. And then I used 3 Proteas. So the first one was Madiba. It's a Protea cineroides. I used Carnival, that was Klokberg Farm close to Paarl in the Western Cape, South Africa, and Susara at Eureka Farms. Obviously it was just drip irrigated, normal cultural practices, nothing funny. So this is difficult to see. This is Cape Town, just to orientate ourselves. So this is the Western Cape, South Africa is continuing here. There's Stellenbosch, many of you might know Stellenbosch, so there's Paarl. And the Proteas were all situated around Paarl, Eureka, and was close there, and then Klokberg, and then if you go up with the N7, then it's about, an hour and a half drive maybe from Cape Town. There's Piket Boerberg, the farm where all the pincushions were sprayed. Okay, so this is the treatments, it's also going to be in the paper if you just want to go check. So the first treatment was a control. Where's my little pointer? It's tired. There's the control there. Then the second treatment, it's a bit odd, but the second treatment was amino acid complex. Third one as well, but this was at the supplier rate. So the supplier said, and sorry for the South African metric units, it's 150 milliliters per 100 liters of water. So that was the application rate. That's what the supplier says we should do. And then for the salts, I also used the recommended rates. It's 150 grams, 150 grams. But then I wanted to see, if you actually work it out, you can see the active manganese and zinc versus the active, not volume, but grams of manganese and zinc. It's much higher with the old sort of sulfate traditionals than what it would be with amino acid, because they say that the uptake is better, so you can use less. So okay, interesting. But then I also decided, well, I'm going to do a higher rate amino acid just for reference, and use this similar rate to what we would on the traditional sulfate. So that's just a higher rate. So you know what that is. It's same as the salts, and then there's a supplier rate amino acid. Okay, that's all you need to know about that slide. Then it's a complete randomized block. So we had 5 blocks, 5 repetitions of 4 plants each. I buffered my spray tank water to pH 5 using Acorite 5, which is a buffer. I suppose you get that similar things all over. I added a surfactant. It's a non-ionic wetting agent. And I sprayed it at a volume of 700 liters per hectare, which I have no idea what that is per acre. So we started spraying when the shoots were 5 to 10 centimeters long, so really in spring at the beginning of the growing season, and we sprayed almost every 6 weeks, more or less. Spring, early summer applications, and there's the dates, and it will also be in the article. So we sprayed it, and then the plants were growing, and then at the end of the growth season we took some leaf analysis and compared them to each other. So we did the leaf analysis in autumn, on the 17th of April, at least 30 leaves for the Proteas because they're bigger, and at least 50 for the Leucospermum because they're slightly smaller, but we need to get to a specific dry weight for the labs. And then if this was your shoot, we never pick the top ones, and they might be a little soft still. So we need to get to that sort of first hardened off proper leaf. So roundabout, sometimes it's a little bit lower down, maybe leaf 9 or 8, but more or less in that region is where we take our leaves. Okay, so the results. So this is for the zinc and all the cultivars, and the black line is sort of just the average. So the control that was unsprayed was the lowest, thankfully. That's always, when the control is the lowest, we're all glad. And then what's interesting is the recommended fancy amino acid chelated product was the second highest or third lowest. And then the salts and the higher treatment was pretty much the same. And if you think about what I said, that the active grams of zinc was similar for these two, that's more or less what you would expect anyway. So it seems initially that, you know, just having an amino acid chelated product, the uptake might be similar in terms of your active, but not necessarily so much better. Yeah, so and then what's also interesting is there's big variation between cultivars. So something like Ayoba Sun here, and they're really good uptake, a little bit lower there and there. So it seems like there was cultivar differences in that as well. So this was then the manganese. So manganese is also in products like mancozeb or diethane that we use as a fungicide and in other fungicides as well, which I realized afterward manganese wasn't not the greatest one to choose, because you can have it in other sprays as well and in your fungicides, but nevertheless, that's what we did. So unfortunately here for this one, I don't know where this thing gone. Well, the control there was not the lowest, and the amino acids didn't really perform, but the salts was similar to the control. So that was kind of like odd for the manganese. Okay, then the Proteas. So you can see immediately the Madiba, which is the Proteas and Aroides, looks completely different if you compare it to the medium head Proteas, if I can call it that, the Carnival and the Susara. And that's something that I suspected for a very long time already, is that if you do leaf analysis of a king Protea versus all the other sort of medium head Proteas, you can't compare the two. They are different animals. They look different, and they also analyze different. So yeah, luckily for the others, the control was the lowest for the medium heads. Then the salts and the higher recommended rate was similar, and the highest, and then just the normal supplier rate was slightly lower than those two, but higher than the control. And the Madiba, I have no idea what was going on here. The control was much higher than the others. I know that often Madiba gets a lot of mancozeb sprays as a fungicide, so that might have influenced the data there. And then for the manganese, interesting here, the Madiba again was very high there. But if you look at the others, the salts actually came out the highest. And then the others were similar to the control. So it does seem like the traditional salts, they're not too bad. Historically, people didn't, knew what they were doing. So I just a little cost analysis. So I took all the product costs and the volumes or the grams or whatever, and obviously a control, there was no cost. The amino acid at the higher rate, this is in rands, so that was for the whole season. It's 3 sprays per hectare. It's 300 rand, which isn't, divide by 18, we'll get to dollars. The complex rate there was say 800 rand, and the salts is about 600 rand. So it's still the cheapest, even though you are adding something like fulvic acid, and half the price of the higher rate if you were spraying that higher rate. But in general per hectare, even if you sprayed the amino acid at the higher rate, 1,300 rand for 3 sprays per hectare is not really that expensive. There's insecticide sprays that's way more than that for 1 spray per hectare, so it's not that high a cost in any case. That was that. Obviously, paying double for something where you get the similar uptake doesn't really make sense. So then you can just go for the lower cost. So this is just some of the data that was published previously. So this is for Leucospermum. This is data from Hawaii, the Canary Islands, South Africa. I think this is worldwide data that she gathered, and this is our data. So for the untreated Leucospermum average, you can see 10 to 25. it's more or less, what you see there. And then also for the manganese, much higher. Interesting levels here. Some of them are much lower, that lower level of 15, 20 there. But yeah, more or less. What's been published previously, the treated is slightly higher. So here comes the problem. Where do you want to be? What should your norm be? Do you want to be at 10 or do you want to be at 30? And that is what we don't know. And we have started a project with Cape Flora in South Africa, because if you have all those analyses, it doesn't really mean much if you can't connect it to something in the field. Was the plants green? Were they yellow? Were you happy with the stem length? Were they short? What was going on? So we have started this sort of triggered a project with Cape Flora, where we're now having leaf samples being gathered and sent into the labs, and then each producer for their block need to fill in. Am I happy with my shoot length? What is my leaf color looking like? So that we can connect the results to something in the field and say, well, all of the blocks that was at a 2, for instance, or optimal shoot length and color, these are the analysis, and that's what we're busy doing now. And then that's just for the Proteas. So the Madiba definitely differs from the other ones, and we're also going to split that in our project in South Africa. But what's interesting here also that the Madiba here was much higher than any of the others. And some others, there's a 5 there and a 19 there for Cineroides that was published previously. And that 7 to 16 seems to be more in the range. There was a 46 for Australia pink ice, so that was also quite high if you compare it to the others. And then for manganese, Australia there also not as high as we've found. There's a Cineroides in the Canaries that was quite high. That's more comparable to what we see. And then there's also Malande. He went up to a 400 max, so that was quite high. It would be interesting to know where that sample came from. So yeah, in conclusion, I think the study really highlights our requirement and our need to have robust norms that we can use, and for a specific time of year send in a leaf sample, see where we are at before we see visual problems and be able to sort that out. There's a perception that the often more expensive amino acid chelated or some of the fancy chelated products are better, and I think that's not necessarily true, and one can look into that in more detail in further studies. And there's also that cost component, which is actually not that huge in the bigger scheme of all your production costs, but it's also something to keep in mind. And obviously if you're doing your foliar spray and you're adding it to a plant insecticide or fungicide spray, then it's even less expensive. So then just add it to the tank and do your foliar spray if you're going to go through the fields anyway. So I think also it will be nice I have actually all the data to expand this to other, to look at the effect on the other macro and micronutrients. Also to consider the effect of your seasonal sprays on your post-harvest quality and your vase life of the product. I think that can also affect it. And to really further evaluate the potential benefits of doing, say, 2 or 3 micronutrient sprays during the season with macros, or if you need some extra nitrogen or potassium, then add that to your spray. So I think there's a lot more work one can do in this subject. So I would like to thank Cape Flora SA for their financial support of this study, and then Dirk, who was our technician, he did all the spraying work for us, and then the growers that participated, Freddie, who's here in the audience somewhere, there he is, Rob and Mary at Pomona, Marika, Bugles Post, and Willie at Klokberg. And that is it.